So every time we've done graphing up to this point, we have done it by creating a table. And creating a table is a fantastic way to graph. You get a few points, put the points on the graph, and you connect them with a line. But if your equation is in what is called slope-intercept form, which is y equals mx plus b, there's an even easier way to graph your equation besides creating a table. And that's what we're going to learn how to do right now, is how to graph an equation using slope-intercept form. So as I just said, slope-intercept form is y equals mx plus b. And in this equation, the letters m and b tell us two really, really important things about the graph. The m in the graph tells us, or sorry, the m in the equation rather, tells us what the slope is. And it usually, if it's a fraction, gives us the slope in the form rise over run. If it's not a fraction, we can make it a fraction. You can turn any whole number into a fraction just by putting 1 on the bottom. So for example, if the slope was 5, we could write it as 5 over 1, and now it's a fraction, and we've got rise over run. So the slope gives us the rise over run, which tells us how steep the line is. Great. Where do we start though? It's all well and good to know how steep the line is, but I need to know where to start to do rise over run. That's where the b comes in. The b tells us the y-intercept. So whenever you are graphing something in slope-intercept form, and the reason it's called slope-intercept form is because mathematicians are so creative at naming things that we took an equation that gave us the slope and the y-intercept and called it slope-intercept form. The y-intercept is your first point. You start off by putting a point where the y-intercept is on the y-axis, and then you use the slope to find your second point. And since it's linear, you only need 2 points to graph the entire equation. So let's try it with this first equation here, which is y equals 2/3 x minus 1. So we start with the y-intercept, and the y-intercept here is minus 1. So our b value here is minus 1, which means the y-intercept is 0, -1. So on our y-axis, which is the up and down one, we go to 0, -1, and that's where we put our first point, 0, -1. The m in this problem is the 2/3, and that is our rise over run. So we have a rise of 2 and a run of 3, meaning from this y-intercept of -1, we go up 2 spaces, or up 2 units, and over 3 spaces, or 3 units. So from this -1, we're going to count up 1, 2, there's our rise of 2, and then we're going to count over 3, 1, 2, 3, and that's where our next point is going to go, up 2 and over 3. Now we have 2 points on our graph. We have the y-intercept, and then we use the slope to find our second point. So we are now going to take our ruler and we are going to draw a line, because this is linear. All equations written in slope-intercept form are lines. We're going to connect these points with a line, and there we go. Slope-intercept form of a line gives us that beautiful line right there with a y-intercept of -1 and a slope of positive 2/3. Perfect. Okay, let's take a look at a second example. So this next equation is y equals -5/2 x plus 3. Just like on the last one, we start with the y-intercept, which is positive 3. b equals 3, which means the y-intercept is 0, 3. So on our y-axis, our first point is going to be at positive 3. There it is. Our m is -5/2, and that is our rise over run. Now this time our slope is negative, and that means instead of going up from left to right, our line is now going to go down from left to right. So instead of going up and over, we're now going to go down and over. Now, I think the easiest way to do a negative slope and a positive slope is just to always go to the right. So if it's a positive slope, go up and to the right, and if it's a negative slope, go down and to the right. Don't ever worry about going to the left with your line. Just do it like you read a book. You read a book from left to right, we graph a line from left to right. So it's up and to the right for a positive slope, it's down and to the right for a negative slope. So we're going to go down 1, 2, 3, 4, 5 units down. And we're going to go over to the right 1, 2 units, and there is our second point. This is going to be a much steeper line than the first one because even though it's a negative slope, 5/2 is a larger number than 2/3. The absolute value is what we're looking at for steepness. 5/2 is bigger than 2/3, so it's a much steeper line. Still linear because it's in slope-intercept form. And there we go. Y-intercept of 3 and a slope of -5/2. Could we still have used a table to graph this? Could we have found some values of x and plugged them in? Of course we could have, but it would have taken much longer to do that than to just find the slope and the y-intercept. Now, finding the slope and y-intercept and graphing like this is only possible if your equation is in slope-intercept form. It has to be in the form y equals mx plus b. If it's not in slope-intercept form, you cannot graph it this way. You either have to make a table or you have to do a little bit of equation work to put it in slope-intercept form. And we'll talk about how to do that a little later on.